All right, let's just jump right in. Ever just stop and look around at, the chair you're on, the clouds outside, even your own hands, and really think, what is all this stuff actually made of? It's kind of a huge question, but believe it or not, everything you see and touch is made from the same basic ingredients. And that's what we're gonna do today. We're gonna break it all down.
I mean, it's one of the biggest questions there is, right? But what's so cool is that the answer is actually pretty simple and kind of beautiful, really. So we're gonna go on a little adventure here. We'll start with the stuff we can see, the big picture, and we're gonna zoom all the way in, like way in, to the tiniest little bits that make up everything.
Okay, so picture this, a solid brick wall, and then a fluffy white cloud. I mean, you can't get much more different than that, can you? One is hard, the other is just vapor. But here's the wild part. At their very core, they're built from the exact same fundamental stuff. And that stuff has a name, which is exactly where we're starting. All right, no more waiting, let's get to it. Our very first stop is to define this one big idea that covers literally everything. And that idea is matter.
And the definition is so simple. Matter is just anything that has mass, that's just, the amount of stuff in it, and takes up space. That's it. If you can weigh it and it has a size, it's matter. So you're matter. The screen you're looking at, yep, matter. It's all matter.
But hang on. As we just saw with the brick and the cloud, matter obviously doesn't always look or feel the same. And that's because it shows up in different physical forms. We call them states. And I bet you already know the big three: solids, liquids, and gases.
So first up, solids. Let's take an ice cube. It has its own shape, right? It's a cube. It doesn't just spread out everywhere. And the reason for that is pretty simple. If we could zoom in with some super-powered microscope, we'd see that all its tiny little particles, its molecules, are just jammed together, super tight. They're all locked in place, holding that solid shape.
Okay, so then we've got liquids. Now, unlike that ice cube, a puddle of water doesn't really have its own shape, does it? You pour it in a glass, it becomes glass-shaped. You spill it on the floor, it spreads out. And that's because its molecules are a bit more relaxed. They're still close, but they're loosely packed, so they can kind of slide and tumble over each other. That's what makes them flow.
And last but not least, we have gases. Think about the air in the room you're in right now. It fills up the entire space, right? Well, that's because its molecules are just totally free. They're flying all over the place, zipping around with a ton of energy. So, here's the big takeaway from all this. Whether something is a solid, a liquid, or a gas, it all comes down to how its tiny little particles are behaving.
Okay, but what are these tiny particles I keep mentioning? Well, it's time to zoom in even more. We're gonna go past the everyday world, past the states of matter, and we're gonna meet the real star of the show, the fundamental building block of literally everything. Get ready to meet the atom.
So here's the breakdown, the simple hierarchy of everything. You start with matter, that's the big stuff we see. That matter is made of these little things called molecules, but what are molecules made of? Even tinier things called atoms. So it goes, matter is made of molecules, which are made of atoms. That's it. That's the foundation of all chemistry right there.
So, the atom. This is the tiniest individual piece of matter you can get. And the name is actually super cool. It comes from this ancient Greek word, atomos, which literally means uncuttable. They thought you just couldn't slice it any smaller. For thousands of years, people believed this was it. This was the end of the line, the smallest thing in the universe. Now, there are two really important things you have to know about atoms. They basically define everything. First, if you take a single atom of, say, silver, it's still silver. It has all the same properties as a big bar of silver. But second, and this is the big one, an atom of oxygen is completely different from an atom of silver. It does differences from one type of atom to another that create all the amazing variety we see in the world.
But here's the thing about atoms. They don't really like to be alone. They're kind of like social butterflies. They're almost always teaming up with other atoms. And when they link up, they build something new. They build molecules.
So when you get two or more atoms and they get stuck together by these really strong forces, we call those chemical bonds. That's a molecule. And here's what's cool about a molecule. It's the absolute smallest piece of a substance you can have that can exist all by itself and still be that substance. It keeps all the original properties. Okay, but here's a little twist. Not all molecules are the same. Sometimes you get molecules that are made of just one kind of atom. A great example is the oxygen we breathe. It's actually a molecule made of two oxygen atoms stuck together. But then you can also have molecules made of different kinds of atoms, like good old water, H2O. And understanding that one simple difference, well, that leads us perfectly into our next section.
This distinction leads us right to the two major types of pure stuff in the universe: elements and compounds. So let's look at what makes them different, because it all comes down to the atoms inside.
Okay, so elements. These are the purest of the pure. An element is a substance made of only one type of atom. I like to think of them as the basic ingredients in the kitchen of the universe. You can't break an element down into anything simpler. We found 118 of them so far, and those 118 ingredients are what make up, well, everything.
All right, now let's talk about compounds. And honestly, this is where the real magic of chemistry kicks in. If there's one thing you remember, let it be this. When different elements combine to form a compound, the thing they create has properties that are totally different from the ingredients that went into it. It's kind of mind-blowing. Let me show you the best example there is. Okay, check this out. Let's look at water. It's made of two elements, hydrogen and oxygen. Now, hydrogen, that's a gas that burns. It's flammable. And oxygen is a gas that fire needs to burn. So you mix a flammable gas with a gas that fire loves, and what do you get? You don't get a huge explosion. You get water, the very thing we use to put fires out. How crazy is that? It's a complete 180-degree transformation. So you take two little hydrogen atoms, one oxygen atom, they link up with those chemical bonds, and bam! You've created a totally new substance, water, with its own completely new set of rules. That, right there, is the power of chemistry.
All right, so we get it. We have pure things like elements and compounds where atoms are chemically locked together. But what happens when you just, mix stuff up without any of that chemical drama? Let's zoom back out for a second.
And that brings us to our last category, mixtures. A mixture is just when you physically mix two or more things together, but they don't chemically combine. And the key thing here is, nothing new is made. All the parts just keep their own original properties. Think about stirring salt into water. The water doesn't stop being water, and the salt is still salty. They're just hanging out together in the same space.
So let's just do a quick recap and put this all on one map. It all starts with matter, right? And we saw that matter can be split into two big groups, mixtures and pure substances. And then those pure substances can be either elements, that's the simple stuff with only one kind of atom, or compounds, where different atoms are chemically bonded to make something totally new. See how it all fits together?
And that's pretty much the whole story. We went from the biggest things we can imagine all the way down to the tiniest invisible particles. You now know the fundamental recipe for the entire universe. The atoms, the elements, the compounds, all of it. All the basic ingredients are laid out for you. So the real question is, now that you know, what are you going to build?